In this video, we are going to go through the Itertools modules in Python and few examples of it. Let's get to it. Hi everyone, Arun here from Nifty Tutes, where we guide you with your educational probes. To learn Itertools, one must know about iterators and generators in Python. I'd recommend you guys to watch the videos that I made about iterators and generators before this. Please find the links for those videos in the description. Alright, now let's explore Itertools. Itertools is a module which is available in Python standard library that comprises of several functions are used to build your own iterators. Every itertool functions returns its own object that is basically an iterator. They are intended to be fast and memory efficient. Functions of itertools can be combined to produce more complex iteration algorithms. Let me walk through the functions of itertools one by one so you guys can understand them clearly. First, let's see two inbuilt functions which returns iterators that are not in Itertools modules. The first function is map. It's an inbuilt function. We don't need to import Itertools module to use it. Map function takes two input arguments, a function and an iterable. Let's say we have a list called L1 with couple of float values in it. Now, if you want to convert this float values into an integer, we can use map function. Map pass int function as the first argument and pass list L1 as the second argument. This map function returns an iterator. So I'm using this iterator object in the for loop. You can see it converted these float values into an integers. Here, every element of the list L1 has been passed to int function and has been converted into integers. The map function basically maps the input function and the iterable. There is a function in the Itertools modules that is very similar to the map function. It's called Starmap. Starmap also takes two input arguments, a function and an iterable. But we use Starmap instead of map when we have the elements of the iterable that are already grouped in as lists or tuples. Let's say we have a nested list called L1. Each elements in the list have two items. Now we can't directly use this list with the map function, but we can use with the star map function. Star map allows each input elements to have more than one item. Let's say I have power function here. Now you can see the output is nothing but 2 power 5, 3 power 6 and 4 power 7. Here two items will be passed as the inputs to the function with every element. The function you use in star map should accept number of input arguments that is equal to the length of every element in the list. Let's say we have three items in every element. For example, we have 2, 5, 3. Then the function you use here should accept three input arguments. That's how star map works. And star map is not inbuilt, so we have to import the Itertools module. The second inbuilt function is called zip. Zip takes two or more iterables as inputs and return a tuple with the element from each iterable in each iteration. Let's say we have two lists called L1 and L2. L1 has 1, 2, 3 as its elements and L2 has A, B as its elements. And if I use zip function here and pass those two lists as inputs, let's run it. You can see it has returned a tuple in each iteration and each tuple has an element from each list 1, A and 2, B. As I mentioned earlier, you can combine the functions of Itertools. Let's say you want to find the length of the tuples written by the zip function. You can use map function to achieve it. Let's say I map the tuples written by the zip function to the length function. And if I run it, you can see it returned the length of each tuples written by the zip function. Okay, when we use zip, you can see that it had returned only two tuples, 1, A, 2, B, but it completely ignored the element 3 from the list L1. That's because zip will stop when the smallest iterable of its inputs exhaust. Here L2 is the smallest iterable which has only two elements. So when it exhausts, the zip The zip function stopped right there. Now, if you want to include this element 3 also in the tuples returned by the zip function, we can use a function called zip longest, that is from the Itertools modules. If I use zip longest here, you can see that it had returned a third tuple with 3 in it, and for the elements from the second list, it included none as the value. All right, let's dive into the functions of Itertools modules one by one. We can segregate the functions of Itertools modules into three categories: infinite iterators, iterators terminating on shortest input sequence, and combinatoric iterators. Let's look into infinite iterators first. As the name suggests, the infinite iterators are iterators that never exhaust. They don't have an end value. So handle it carefully or you might end up writing a program that runs forever. There are three infinite iterators. The first function in the infinite iterators is count. Count just generates numbers from the given start value. Let me comment these two. We don't require this now. Let's use count without any input passed to it. If I run this, you can see that it keep on generating numbers. As I mentioned earlier, there is no end value for infinite iterators. This will run forever. Let me stop this. The count function can take two input arguments. First one is start. Start tells the count from where to start its number generation. The default value of start is 0. If you didn't pass any value to the start, then count will assume 0 as the start value and it will start generating numbers from 0. Let me comment this for loop as this function will never end. Let's use next function and let me pass start value as 5. If I run this code, you can see it has generated numbers starting from 5. The second input argument of the count is step. Step will decide the next value in the sequence generated by the count. The current value of the count will be incremented by the step value in every iteration. The default step value is 1. So that's why you can see the current value is incremented by 1 in each iteration. 5 plus 1, 6, 6 plus 1, 7, 7 plus 1, 8, and so on. We can also give different step value by passing it as an input argument. If I give step equal to 2 and if you run this, you can see it has generated 5 plus 2 7, 7 plus 2 9, 9 plus 2 11, and so on. Okay, if I use the iterator written by this count function in the for loop, it's gonna run indefinitely. So when to use it? We can use the infinite iterators with the iterator that's obviously gonna end at some point. Let's say we have the list L1 and if we want to add sequence of numbers in front of every elements in the list L1, we can use count and zip function together to achieve it. Let me comment this statements. Let me uncomment this for loop. Let me take this count function in the variable called C and I'll create one more variable called result for zip function. And if I pass the count and this L1 as input to the zip function, let me remove this. Let's have a plain count function. If I run this, you can see it generated a tuples with every element of a list in it, and also it included a sequence of numbers in front of every elements in the list. Here we have used zip and count function together. That's the power of Itertools. You can combine any functions to create complex algorithms. The second function in infinite iterators is cycle. Cycle returns an iterator that repeats the elements of iterable that passed as an input to it. Let's pass this list L1 to the cycle function. Let me remove this and let me comment the for loop and let's test it with this next functions. Let me have some more. And if I pass this list L1 to the cycle function, let's see what happens. You can see that it has printed the elements of list L1 again and again. It printed from 1 to 3. Once it printed the last element, it again started from the first element of the list L1. It goes on in cycle. It will never end since it's an infinite iterator. The third and final function in infinite iterators is repeat. Repeat does nothing but just repeats the object passed to it as an input. Let's say we have repeat function with 1 as input. Let's have less number of next functions. If I run this, you can see it repeated the value 1 three times. That's because I call next function three times. If I use this iterator in for loop, it's going to repeat the value 1 forever. We can set limit to this repeat function using times argument. If I set times equal to 2, this repeat function will repeat this value 1 only for 2 times. Let me run this code again. You can see it has thrown stop iteration exception after repeating the value 1 twice. That's it with infinite iterators. The next category of Itertools functions is iterators terminating on shortest input sequence. Unlike infinite iterators, we will pass one or more iterables as input to the functions belong to this category, and they will stop once the shortest iterable is exhausted. There are 12 functions in this category. We have already seen two functions of this category earlier in this video. They are zip longest and Starmap. The next function we are going to see is accumulate. The accumulate function takes an iterable and a function which is optional as inputs and returns an iterator that accumulates the elements of the iterable using the input function. Let's say we have a list called L1. Let's use this list with accumulate function. Let me comment this next statements. Let's use for loop from now on. If I run this, it generated some sequence. As I mentioned earlier, the input function for accumulate is optional. If you didn't pass any function, accumulate will use addition as a default function. So here what's happening is first element of the iterable will be returned as it is. Second element will get added to the first element. So 1 plus 2 is 3. And now the current element is 3. 3 will get added to the next element, which is nothing but 3. So we got 6. It's accumulating the elements of list L1 based on the input function. We can also use our own function as input to the accumulate. Let's say we have a function called f which takes two input arguments and returns this complex expression as output. If I use this with accumulate, you can see that it returned the sequence based on this expression. The next function is called chain. Chain accepts one or more iterables as inputs and returns an iterator that chains them together. Let me remove this function. Let's say we have two lists called L1 and L2. If I pass both of them as input to the chain function, let's see what happens. You can see that it has returned all the elements of list L1 first. Once the list L1 was exhausted, it has returned all the elements of list L2. It chained both L1 and L2 as single list. Okay, let's say we have a nested list called L3. Let's try to pass that as input to the chain function. You can see that it has generated a list in every iteration. That's because every element in the nested list is a list. Now, what if we wanted to return elements of nested list one by one? To solve that purpose, we can use the alternative constructor of the chain function. That's called from iterable. We cannot directly use the from iterable. We can only use it with the chain function. From iterable also can take only one iterable as input. Let's run this. See that it has generated one element at a time even with the nested list. The next function is called compress. Compress takes two iterables as inputs. The first iterable is called data to be written by the iterator. The second iterable is called selectors, which contains boolean values that decides which element from the first iterable should be returned. Let's say we have two lists called L2 and L3. L2 has A, B, C, and D as its elements, and L3 has few boolean values as its elements. Let's try to pass them as input to compress function. If I run this, you can see that it has printed A and C. That's because L3 has true as first and third element. So it printed the first and third element of L2. It skipped B because second element of L3 is false. So the compress will return only the values that are associated with true. it will skip the values associated with the false. It also skipped the value D. That's because L3 has only 3 elements. So the compress will stop when the shortest iterable of its input is exhausted. The next function is called FilterFalse. FilterFalse takes a function and an iterable as inputs and returns an iterator that filters the elements of the iterable for which the function had written false. It's like opposite to the filter function. Let's say we have a list called L1 with few integer elements in it. So let's say it has some values, and let's say we have a function called f that takes an input argument and returns true if that input argument is less than or equal to true, else false. So let's use both this function and list in the filter false function. If I run this, you can see that it has printed 3 and 4. That's because the input function f would have returned true for every elements that is less than or equal to 2, which means except for 3 and 4, for every other elements it would have returned true. The filter false will filter the elements if it gets true from the function f. So it would have got only false for 3 and 4. That's why it printed only 3 and 4. The next function is called dropwhile. Dropwhile is similar to filter false. It also drops the element that gets true from the input function. But once it gets false, from that point it prints every elements of the list despite of the result of the input function. Let's use the same list L1 and function f with dropwhile. Let me run this. You can see that it has printed all the elements from 3. That's because this function f would have written true for 1 and 2. Once it gets false for 3, from that point dropwhile will not consider the result of function f. It will print every element till the list get exhausted. The next function is takewhile. Takewhile is exact opposite of dropwhile. Takewhile prints the elements that get true from the input function and stops right there once it gets false. Let me use the same example with takewhile. If I run this, you can see it has printed 1 and 2 and it stops right there. That's because our function would have written false for element 3. It won't print after that. The next function is called groupby. The definition of groupby is a bit confusing, so let's directly look into an example so that we can understand it easily. Let's say we have a list of dictionaries called employees. Each dictionary in the list contains an employee details. Let's say we have a function that returns the values of key that will be used by the groupby function. Here in our example we are going to use job as the key, so this function returns the value of job of each employee. The groupby function takes an iterable and function as a input arguments. This function will return the key values that will be used by the groupby function to create groups. Let's run this code. You can see that it returned two values. This is nothing but two groups. That's because we use job as the key. Job has two distinct values. So it created one group for one each value. So developer is a one group and manager is one group. Here developer is a key. There is a value associated with it that is nothing but another iterator. So to see the values of this iterator, we have to pass this in another for loop. Let me uncomment this and let me run this. You can see that under developer group it added employee Arun and Jack because they both are developers, and under manager group it added employee John and Smith. That's because they both are managers. We can also use different keys. Let me try using age here. Here every employee belong to age 34. So it has created only one group and added all the employees under that group. It is similar to groupby in SQL. The next function is called islice. Islice works same as list or tuple slicing. Islice accepts an iterable and three input arguments. Let's say we have a list L1 with few elements in it. Let's remove this function. If I pass this list as input to islice with 2 as another input argument, You can see it printed 1 and 2. That's because 2 here tells where to stop. It's a stop value. Now if you want to tell the islice function where to start and where to stop, you have to pass one more argument. Let's say we pass 6, and if I run this, you can see it started at the second position and stopped at the sixth position, which is nothing but 3 to 6. If you want to print till the end of this list, you have to mention none. You can see it printed all the elements from the second position. The fourth input argument we can pass is step. So if I pass 2 and run this code, you can see that it has printed every second element in between the start and stop position. The final function in this category is called T. The iterators written by the Itertools function cannot be used more than once. If you want to use it again, you must create a new object. For example, let's use this object of islice again in another for loop. If you run this, you can see that it has returned nothing from the second for loop. That's because it has been already exhausted in the first for loop. To use this islice object again, you have to create a new object. That's where the T function comes in handy. Using T function, you can create n number of independent iterators from existing iterators. The T function can take two input arguments. First one is an existing iterator. Second one is number of copies of that existing iterator should be created. Let's pass this islice object into T function. Let's try to create two copies first. Result is the first argument and number of copies is the second argument. If I use C1 and C2 here, you can see that it has printed the values of islice object twice. That's because we created two copies of it. If you give 3 here, it will create 3 copies. So that's what this number does. The important thing to note here is once you have used this iterator object in T function, you should not use it again. If you use this here, you can see that it has printed only once. That's because the iterator used inside the T function should not be used anywhere in your code. Else, the iterators created by this T functions will not work. That's it from the category iterators terminating on shortest input sequence. Now let's look into the final category called combinatoric iterators. There are 4 functions in this category. The first function in this category is called product. Product takes one or more iterables as input and return the Cartesian product of those iterables. Let me remove this for loop. We don't need this anymore. Let me remove this as well. Let's say we have two lists called L1 and L2. First, let's pass only one list to this product as input. If I pass L1, it just returned two tuples. Now, if we pass L2 as the second input argument, now the actual Cartesian product from between L1 and L2 will happen. You can see it has generated 1A, 1B, 2A, 2B. It's like cross join in SQL. You can pass any number of iterables as input to this product function. There is one more input argument called repeat. If you didn't pass any value to this repeat, product will assume repeat value as 1 by default. Let's pass 2 and run it. You can see it has generated more values. So what's happening here? If I give repeat 2, it is like having L1 and L2 passed as input again to the product. So the Cartesian product will happen on all these 4 lists. That's why we get 4 values in each tuple. The next function is called permutation. Permutation takes an iterable and R value as inputs and generates all permutation of that iterable in group of R number of elements. By default, R value is none. If we didn't pass any value to R, then the number of elements in the groups written by the permutation functions will be equal to the number of elements in the iterable. Let's say we have a list L1 with 3 elements in it. Let's remove this. If we use permutation function and pass that list L1 as input, let's run this code. You can see that it has generated permutation values of this list L1 in group of 3 values. That's because the length of list L1 is 3. If I pass 2 as input value for R, then you can see it has generated the permutation values in the group of 2 elements. The next function is called combination. Combination also takes an iterable and R value as input. Let's use the same example with combinations. You can see that it has returned all the combinations of list L1 with R elements in each group. The difference between permutation and combination is in permutation order matters, but in combination order doesn't matter. In permutation 1, 2 and 2, 1 is different. So it will print both 1, 2 and 2, 1. But in combination 1, 2 and 2, 1 are same. So you can see that it didn't print 2, 1 here. That's because order matters in combination. The final function is called combinations with replacement. In combination, every group that generated by combination object will have distinct values, but combination with replacement can have duplicate values. For example, if I use the same example with combination with replacement, you can see that it has generated 1, 1. 1 is repeated in the same group, but in combinations, you cannot see this. Combinations will have every group with distinct values. That's the difference between combinations and combinations with replacement. Awesome. We have covered pretty much all the functions in the Itertools module. Thank you for watching. If you like this video, please give a thumbs up and subscribe to this channel for more. Hit the bell icon to get the instant notifications. If you have any queries or feedback, feel free to leave it in the comment sections. Thank you guys once again, and I'll see you in the next tute.